Today I'm working on the spoiler plate for the 3018 desktop CNC machine that I've got. I'm using a 3/4 inch piece of MDF as the spoiler plate material, and I've just marked out all the locations where I'm planning to drill M6 clearance holes, as well as to countersink some brass inserts. So there's enough material, so that it won't get pulled through. So I'll be using Forster bits to do that. The actual mounting of this MDF to the board is going to be done with the T-nuts that came with it, and I will just put in 4 locations to tie the board to the aluminum plate flat, and once that is done, then I'll send a file through that will use a bit to basically flatten out the surface and square it up relative to the cutting head. I've got 4 countersunk bolts that I've inserted. Those are just kind of loosely in there, that will go with the T-nuts and secure it to the aluminum plate. And there's several, like there's 8 I think 12 millimeter M6 brass inserts I've put in. You can see on the back, located around the workspace that I expect to put my PCBs down on. And so this now needs to be bolted down to the aluminum plate, and then the leveling bit which I'm going to insert and then zero the Z-axis on. I'm going to be taking off probably about a millimeter off the top so that this work surface is level or square to the bit depth or the bit travel, and that way when PCB is actually clamped down, we're not going to be seeing varying widths on the milled trace spacing, and hopefully that will work out okay. Now I've gone and bought some of the clamps that you can get for this machine, and I've removed the T-nut on the bottom, so this is just one of the brass inserts. I just was checking to see what the fit would be like. So these will go into the locations where I put in the brass inserts in the spoil board, and hopefully they will work well for securing. I actually like these ones better than the crappy little metal pieces that they provided, but I'll use what I have at the time. So once I get this all mounted up, I'll show what I did on the G-code for creating a file to load into this to do the leveling. One thing to kind of note is that this board size is larger than the actual workable space, because if you notice with the head, as you're traveling across, it's going to hit the limit switch, which is out pretty far. So pretty much all this end of the board is of not any use. So it will still be used for providing an outside clamp area, for an inner larger board, but realistically you don't have as big of a work surface. Like, it's not the size of the aluminum table. So to create the profile for doing your spoil plate, it is actually not that hard to just create a simple text file off of a Excel file to create the file that you're going to put into Candle and have followed by your tool. In my case, I've got an Excel sheet set up with the dimensions of my spoil plate, and you can find that by moving your tool head around to just find out just before it hits the limit switches as to how far you can run. If you hit the limit switches, then the unit will shut down or stop operation and throw a fault. So you always want to stay just inside the limit switches. So in my case, I figured mine out to be about 263 millimeters in the X direction and about 155 millimeters in the Y. The actual Z cut depth is dependent on how thick your spoil plate is. So everything starts off for me in the home position for the Z axis, which is sitting at its topmost location. So with Excel, you can use the text concatenate operation to combine the values that you create from creating the milling rows that you need to surface the spoil plate. And the spoil plate needs to be level against your tool so that you're not going to get different heights of cutting. So that wasn't that hard to do, and you can figure out how many passes you got to make. The thing that was a problem was figuring out what the feed rate should be, and obviously this is a pretty not very stiff made machine, so if you try to force your bit through the material too quickly, what will end up happening is that the head will flex and you'll get an uneven cut. So I did play with the feed rate, and my Excel sheet was set up so that I could do that very easily and have it inserted in the correct location where I'm setting the tool speed, as well as the feed rate for moving the tool from across the spoil plate. So if we see in the file here, I have it set up now that I can just simply make the changes to my parameter. So I'm going to actually keep this at a Z cut depth of 5 millimeters so that my tool doesn't go into my freshly prepared spoil plate. And if I want it to be a 1 millimeter cut, I would simply just add 1 millimeter to it, which would update the cut depth, and it doesn't really change the profile. So with the Excel sheet, if you have a different surfacing bit that has a different diameter, you can add that in and then figure out what your offset will be, like how much of an offset you want to have for each of the rows so that they overlap. In my case, I was using a 1-inch bit, and so that's like 24.4 millimeters. And so I wanted to basically do each row overlaid half of the next row, just to make sure that there wasn't any grooves or anything forming. And this actually worked out pretty good. So one of the things you have to do is you have to spend some time figuring out what the G code is actually doing for these simple moves, and it isn't terribly complicated, but once you've done that, then you can then set up what you want to do at the beginning of your leveling to the end of it. So in my case, with this file, I was able to then, as I said, create the text file or the text for the G code, and I can just copy that and bring it into a text editor and then just paste it into the file and save it. So now that is the file that will load into Candle. So if we bring up Candle and I open up the file that we just created, you can see that toolpath is shown to be all these rows. So what it actually does is goes from left to right, goes up half a tool bit diameter, and then goes right to left, and then again up half a tool diameter, and continues on until it gets to the end, and then it goes back over the edge to clean it up and goes all the way around. So your feed rate on this again depends on how flat of a surface you want. I used a relatively slow feed rate, so this took me about an hour and a half to go over, because I wanted this to be very level, because I'm going to be milling PCBs and I don't want any funny rises throughout the board, so that the trace widths are fairly consistent. So before you can actually use this, you need to home your machine. So I'm just going to quickly do that with mine, just to show you. So now that it's homed, we need to zero the z-axis so that you know how far above the material you are with your bit. So the z-axis stuff is not as intuitive as it might be, and you have to do some internet searching. I did plant my tool head into my spoil board a couple of times while I was figuring this out. So I made, like, Candle has 4 user buttons that you can program. So I made some profiles to make it easier to set up the machine for when I go to do a PCB. So one of these was to go to the center of my workpiece. So once you're at the center of your workpiece, this is where the PCB will be located. Now this is just the Z probe that came with the CNC. It is pretty thick, so if you actually were working on material that was much thicker, you're kind of limited to only so thick of a material when you use those pucks. So you want to use a much thinner zeroing probe if you're going to have a thicker material. For my case with the PCBs, it's pretty thin, so I'm not really too concerned. So with the Z probe, once it's in place and you've got it clipped, you can just come up and hit the Z probe button. So what that will do is it'll have the tool come down until it touches the probe, and once it touches the probe, I've actually modified mine to lift up a little bit and then come back down and touch it again at a much slower rate, so that the consistency should be a lot better. So I'll go and actually show you that. If you go into the service settings in Candle, you come down, so here's where the probe command can be inserted, so you can actually modify your code to perform a slightly different probe profile if you want, and I've done that. I can show you what I've done for that. And then you have your other user program buttons here, and so these have been created to basically move the table around so I can get easier access to certain things, or if I'm going to be doing probing, like setting up the Z probe in the center of the workpiece. So if I bring up Excel again, I think where I got here. Actually, I think it's in my. Sorry, it was in the text editor. So for the Z probe, you'll notice that there's actually quite a few lines to do a Z calibration. In the very first one, this G53 is using the machine coordinates, so that's after you've homed your machine. Those are sort of your absolute coordinates that you want to use to get any place specific and know that you've actually gone there. And so that is what G53 does. So that can only be used on a single line. You can't just set that and then say, well, I'm going to be running machine coordinates for the rest of my G code. It's only on a per line basis. So in this case, I'm saying go use my machine coordinates, and then use the absolute linear move, and then go to the z-axis at 0 millimeter location at its fastest travel rate. So that's the G0 puts you at the fastest travel rate that you can do with your machine. So that puts me with the bit at its highest level it's going to be. And then I'm going to go and I'm going to say I want to do a relative move. So G91 is a relative move. I want to use metric, which is G21, and then the G38.2 is your z-axis probe calibration, and so it will travel down 20 millimeters in the negative direction from its location at a feed rate of 100 millimeters per minute. And so it'll do that until it hits the probe. If it doesn't hit the probe, it'll throw a fault and it'll just stop. So assuming that we hit the probe, the next thing I want to do is do another relative move where I just go up about 1/4 millimeter and then do another Z calibration after that, but a much slower feed rate. So it's like 10 millimeters per minute, so really, really slow. So this gives you less inertia in the system, so that when it touches it, it stops much quicker. And then G92 applies an offset to the work coordinates, and so now you're putting in you're basically adding the thickness of your probe. So that 13.99 is what I measured with my calipers on the Z probe that's sitting on the workpiece right now. So at that point, the Z probes is calibrated, and in the workspace, you now have the surface of your workpiece well defined as to what its level is. And so my last line is to go to use again machine coordinates, which is the absolute coordinates of the system, and drive the z-axis up to 0 location as quickly as possible, so it just gets it out of the way. So at this point, the z-axis probe calibration is done. So I'd really recommend spending some time just to understand what the basic G-code functions are and how you use them. I would recommend just using some of the programmable buttons for Candle if you just want to play with what does it do, and you can do it somewhat safely, but have your hand close to the emergency stop button that's on the side of the machine so you can stop it. That's one of my beefs with this thing, is that button is not in a convenient location to hit very quickly. So you might want to modify your unit to have a remote emergency stop button that is closer to where your computer might be, or where the little dongle might be.